Alright, today I will be solving the problem find minimum in a rotated sorted array. This problem kind of builds on our understanding of binary search, so I would highly recommend that if you haven't already learned how to do binary search in a sorted array, I highly recommend that you solve that problem first and understand what is going on, right? So let's begin. So we have been provided with an integer array nums. In this case it is 1 2 3 4 5 and 6, which has been rotated n amount of times. In the first example, this integer array of this has been rotated four times. So we have 3 4 5 6, right? So 4. And then the second example, it has been rotated 6 times. So when it has been rotated 6 times, it essentially means it's like the same list, because if you can not tell it, like we only have 6 values, right? So it means that it is essentially the same list. So let's begin on how to solve this problem, right? We initialize our 2 pointers. We say left and right. Left at 0, and then right would be at the length of nums -1, which in it, so left it is pointing at 3, and then right is at index 2, right? You can say while L is smaller than R. Now see how I said while L is smaller than R and not this? I'll explain why I did that once I go a little deeper in the explanation. Now we can find our middle index. Mid is equals to left plus R divided by 2. So that essentially returns our middle index, right? And we say if the number at value mid is bigger than the nums at right, left is equals to mid plus 1. Alright, so let me explain what happened. So when we did our mid, let's say we landed at 5, right? We say if the number at mid, which is 5, is bigger than our number 2, then we know for a fact that we cannot find our solution in this in the leftmost side of our array, right? So we say left is mid plus 1. So left is right here now, and then the right side is right here now, and we essentially keep doing this. So in this case, now we find the middle index, and the middle index is indeed not bigger than our right index. So we just say else right is equals to mid nums at R. Alright, so let me run this first to see if it works or not, and as you can see, it does. So let's see what happens here, right? So we landed at 5, and we said if the number at mid is bigger than the number at right pointer, then we know for a fact that our number does not exist here, right? Because the minimum value is 1. It does not exist on the left side. We say left is equals to mid plus 1. So we are landing here, right? So this is our new array essentially. We run our this section on this array. We say left plus right divided by 2, we land at 1, right? And we go to our if block. We say if the number at mid, if number 1 is bigger than 2, left is equals to mid plus 1, which is not the case. 1 is not bigger than 2, right? So we just say else right becomes mid. Right is so left is right here and 1 is right here, and we keep essentially doing this until left and right are at the same position, and we exit our loop, right? Because that's why we didn't say like this. That's why we said one left is smaller than right, and we just return nums at R. We can also just return nums at left. It's pretty much the same thing, and it should work because left and right is literally at the same index. So hopefully that was easy to understand.